All right, so this last page, and I want you to try to do this without me. So ideally, just pause this, see if you can do these problems, and then unpause it. Just check if you're right or if you get stuck. So what we want to do is practice doing finding areas under the curve using the methods that we've learned: Riemann sums, geometry, and then evaluating definite integrals with our calculator. So pause this, see if you can do these. All right, so the function absolute value of x minus 2 minus 1 uh, is an absolute value that's been shifted 2 to the right and down 1. So it's going to look something like that. And we're evaluating from -2 to 3. Um, let's try to get this a little bit more exact. And so if we want to do a Riemann sums, you know how to do that. So Riemann sums, we need to, well, you don't need to use your calculator, but we can use our calculator. Riemann sums with n equals 5 means that you're going to have 5 rectangles, and we can go to our calculator, and we're going to go to y equals, and we're going to put the absolute value, so math over to num, absolute value of x minus 2, so x minus 2 minus 1. So we get our function into our y1, and then what we need to do, quit out, and we're going to go to our program, Riemann sums, and our left bound is -2. Our right bound is 3. For x choice, well, since we're doing a right-handed Riemann sums, our x choice is going to be 1. We want to have n equals 5, and it's going to approximate the area for us at 2. So that's our Riemann sum approximation. This is do it graphically using geometry. Well, I've drawn it up here, but I think I'd like to redraw it a little bit neater. So, well, not neater, but making sure that I go through the right points. So it's an absolute value that's shifted over 2 and down 1. So it's going to go through 3. It's going to go through 1. That y value is 1. So getting the points that we're going through. And we're going all the way over to -2. So when x equals -2, um, we've got the point -2, comma, 3. Okay, so using geometry, what we can do is we can construct a bunch of triangles. So we know that this triangle here has height 3 and a width of 3. So the area of this triangle, and the green area is positive because it's above the x-axis, the area of that is 9/2. And then we want to look at the area of our triangle below the x-axis. Well, that's this triangle here, which has a length of 2 and a height of 1. So the area of that red triangle would be 1/2 2 times 1, or just 1. So my total area is the positive area, 9/2, minus the below area, so -1. So 9/2 minus 1, we get 7/2, or 3.5. So that's using geometry. So we did our Riemann sums, we did our geometry. Now we want to use the two different integration functions on our calculator. So these are functions that you need to be able to use both. You should be able to use both. So the first one, using the fn int. Remember, we go to math, and then we're going to go down, scroll down to fn int. So that's I'm integrating. And what am I integrating? Well, I'm integrating my y1, the function that's in y1, just to check, in y1 we have my function. So I need to tell it to integrate y1. So vars, y vars function y1. And remember, we're always going to put comma x. That's saying that the variable is x. And we're integrating from -2 to 3. Those are my limits. So -2, comma 3. And hopefully, unless I did something wrong with the geometry, we should get 3.5. So you press enter. And the calculator gives us 3.4999999. Well, it's making a little bit of approximation, so we can recognize that that's really just 3.5. So that is using the function integration function fn int, and we get 3.5. So we can use that. And the last one is using the definite integral function of your calculator. So just as a reminder, you go to your calculator and always make sure that the function is in y1. It is. Then we press second calc, and we go down to the definite integral sign. We press enter, and we're going to integrate, and there's our function. We're going to integrate from -2 to 3. And as soon as we press enter, it's going to start shading in our area. And once again, the calculator makes slight approximations, but we get that the area is 3.5. So hopefully you're able to do all these methods. These are the 4 methods that you need right now to approximate area under the curve. The first one is Riemann sums, and we were doing that the other day without a formal name for it. The next one is using geometry. The next one and the next 2 are both calculator functions that we've learned to approximate definite integrals. And in the next couple days, we're going to learn how to evaluate these definite integrals without the use of the calculator.